this video, we'll be defining friction. This is podcast number 3 for chapter 4. We're going to start with some definitions. The force of static friction is defined as the minimum force needed to get an object moving. The symbol for the force of static friction is F sub S, meaning force static. The force of kinetic friction is the force needed to keep an object moving. At a constant speed. And the symbol for the force of kinetic friction is F sub K. The coefficient of static friction is for an object sitting on a flat surface, it's the percent of the weight you have to push with to get the object going. And again, this is for an object sitting on a flat surface. So, I have an object sitting on a flat surface where Fg and Fn are equal and opposite. And if I have a force of static friction pushing to the side, the coefficient of static friction would be defined as the force of static friction over actually the normal force. So if it takes me 20 newtons to push and get a 100 Newton object going, that would be a coefficient of friction of 0.2 or 20%. The coefficient of kinetic friction is the percent of the weight needed to keep an object going. And the definition mathematically is coefficient of kinetic friction equals force of kinetic friction over normal force. I'd like you to pause and take a minute now and think about what happens to the forces of friction when we're dealing with an object whose normal force does not equal the gravitational force. And there are several different ways that we could make this happen. I could have a book sitting on a table with a gravitational force and a normal force. And then I could decide to press down on the book with an applied force. And what would happen is the normal force would actually extend so that it would balance out both the applied force and the gravitational force. And as that normal force increases, the force of friction between the book and the table would increase as well. So it's important that we use the normal force and not the force of gravity when we're computing the coefficients of static and kinetic friction. Let's do some examples to make this a little bit more clear. Example 1, a man pulls a box with a weight of 250 newtons across the floor at constant speed. He applies a force of 100 newtons at an angle of 30 degrees to the horizontal. Find the value of the normal force and the value of the force of kinetic friction. So let's start with a force diagram. Here's our box. The weight of the box is 250 newtons. He applies a force of 100 newtons at an angle of 30 degrees. Now I can see right away before I move any farther that I'm going to need to resolve this into components. And I know my 30, 60, 90 triangles, so I know that if the hypotenuse is 100, I know that the short leg will be 50 newtons and the long leg will be 50 times the square root of 3 newtons. So that's FAY and FAX. Next, I know there must be a frictional force balancing out FAX, and that's a force of kinetic friction. And then I also know there must be a normal force, and my normal force is going to be less than the force of gravity. If I write a formula for the variables that are in the vertical direction, I would have FG is in the vertical direction. I would have FAY is in the vertical direction. And finally, I would have FN is in the vertical direction. And the sum of those three variables must be 0 since the box is not floating or going through the floor, down through the floor. Since it's not moving up or down, the sum of those three must be 0. So that means I can calculate Fn because I know that Fg is negative 250. I know that Fay is 50, and therefore I can calculate Fn. Fn must be 200 newtons. Likewise, for an object that's being pulled at a constant speed, I know that Fax and Fk must be equal and opposite, which means that this force of kinetic friction must be 50 times the square root of 3 newtons. Notice here I said the value of the force of kinetic friction, so I'm not going to be too concerned about the direction, although it is true that when the force is to the left, we often call it a negative value. Let's try example 2. A man pulls a box across the floor at a constant speed. He applies a force of 100 newtons at an angle of 45 degrees to the horizontal. Find the value of the normal force and the value of the coefficient of kinetic friction. So this is basically the same problem. Let's see if you can figure it out along with me. We've got Fg. We've got an applied force. See if you can remember your special right triangles. The two legs would be 100 divided by the square root of 2, or if we rationalize the denominator, that's equal to 50 times the square root of 2. We'll have a normal force, which is less than the force of gravity, and we'll have a force of kinetic friction, which is equal and opposite to 50 times the square root of 2. So again, to find the normal force, I'll look at the vertical forces, Fg, Fay, and Fn. Fg is negative 250, Fay is 50 times the square root of 2, and Fn is my unknown. If I were solving this problem without a calculator, when I solve for Fn, I would get 250 minus 50 times the square root of 2 as my answer. Fk, then, the value of that would be just 50 times the square root of 2. Because, again, these are my only horizontal components, and they must cancel each other out.